All right.
There she is.
Mr. Crater, it is 10 o'clock, and so if you would like to,
I'll get us
start on,
started.
that'd be great.
Thanks, Dave. First of all, I'd like to thank everybody for attending our continuing Sharing the Knowledge series this morning. So appreciate you taking time. My name is Joe Crater. I'm EVP of Sales here at SPL. Welcome to Season 1, Episode 4 of Sharing the Knowledge series. This episode is entitled Natural Gas and Hydrocarbon Liquid Sampling, and it's another subject that's near and dear to my heart. Again, as you can see, we're in multiple locations, trying to comply with the local requirements for COVID-19, social distancing, and all that good stuff. So continue to do what we're doing. We're moving on the downside of the curve, so I think it's working. So if everybody continues on, we'll be in great shape. We're also facing a hurricane down here on the Gulf Coast this morning. So if anybody's listening that's in that area, to please stay safe, heed the local evacuation orders, and hunker down and stay safe during that time. And you know, there's a joke around here. We've had the COVID plague, we've had hurricanes, and you know, Friday, stay tuned. Plague of the locusts will probably come upon us on Friday. So in all seriousness, during the dialogue today, we'll give you good pointers for making sure that you capture great samples. Just to add, we do warranty our sampling. If you know, through no fault of your own, the clients, through fault of our own, we catch bad samples, we will go back out and re-retrieve those samples. And that's how confident we are on the amount of training and that we spend. And today you'll get to speak to primarily to two of those gentlemen that participate in that. One of the things I'd like to add is that we do have an abundance of training, not only on sampling, but all our processes, following SOPs and all those things, and of course the API AGA standards as well. Today we'll have 4 well-qualified panelists, plus we've had a couple that just joined us. I know we've got Chris Staley on the line, but also Joe Landis. Joe is one of our retired and brought back to life. I think we'll call him Lazarus. He is now working with Dave Curtis with our production allocation team as well. So Dave's on the line, Joe's on the line today to help. So we're very happy to have Joe participating. One of the emphases we're going to start out with one of our core values today. We're going to talk about safety, and that's how we're going to start the webinar. So Dave will hit on that when he opens up. Dave's going to be our moderator today, and hopefully we can keep him in that role as much as possible. I'm just kidding, Dave.
No, you know I have a hard time keeping my mouth shut. So
but we love it. We love it. Dave's our EVP of Corporate Strategy and actively manages our digital compliance, technical services, and software groups. We have Dee Orr. Dee is located in Arlington, Texas today. Dee is a senior technical support measurement specialist and has over 30 years of measurement experience. And most commonly, if we have an audit, Dee will be involved in those technical audits for our clients. We also have Jim Reed in Houston. Jim, raise your hand. Jim is also a senior technical support specialist and has over 20 years of measurement experience, and also heads up our field training group, and also works with our allocation group as well. We also have Z Sheikh. Z, raise your hand. Z is our petroleum engineer, and he works with our digital compliance group. So looking forward to the class today, guys. Dave, take it away.
all right, let me share the screen here. Stand by. All right, so as Joe said, thank you everybody for joining in. Just like for those of you who have joined the classes before, because this is a webinar, it's tough to hear all the voices. I wish we were all in the room together. That's a lot more fun. But we do have your mics muted, unfortunately, just because to avoid background noise, that type of thing. But you do have the opportunity to ask questions. In your panel for your Zoom, there's a Q&A button. If you click that, you can send a question, and Z will be monitoring those. And any questions you have, he will shout them out, make sure they get answered. Don't wait till the end. Don't hesitate. You have a question, ask it right at that moment. Z will interject at the right moment and make sure we get that answered for you.
Sorry.
So as Joe mentioned, we try and cover, something core values each time, because our core values are important to us here at SPL, as I know they are at every one of your companies. Last time we covered integrity. And so today we want to cover safety, as Joe mentioned. And before we get into the safety, which we're going to specifically dial in the topic that we're talking about today, I do want to reiterate what Joe said. There is a hurricane that's coming down on the Gulf. And so those of you who are in the area, be safe, heed the warnings. If you see water ahead, turn around, because you never know how deep it is, that type of thing. So just be careful, be safe, and take care of your loved ones. Okay, so health and safety, of course, is important when you're out there collecting samples, even more so. When you're out there collecting samples, you're out in the environment, you're possibly in a classified area, so know what the classification is for the area that you go in, but you're dealing with a lot of hazards, high pressure, you're dealing with potentially high temperatures, you're dealing with potentially toxic compounds such as H2S, that type of thing. And of course, we are talking about natural gas and hydrocarbon fluids, so we are dealing with flammable materials. So need to take all that in mind, be safe with it, treat each sample as a potential health hazard, because you don't know what's in it and you just don't want to get that coated on you. And I'm going to throw that out, that even if you're not collecting a sample, let's say you're pulling a plate out of an orifice meter. There's a lot of liquids and stuff that goes along with that. You don't want to get that stuff on your hand. You have cotton gloves, it'll soak in those cotton gloves, which then just holds it to your skin. So be careful, treat everything like it's a potential health hazard. And because it's a potential health hazard, watch your disposal. Make sure you collect everything, make sure that's properly disposed of. When you're pulling samples, there is a lot of times some outage, that type of thing that you're going to have that Dee and Jim will go through. You want to make sure you collect that, dispose of it in a proper manner. Make sure you're wearing the right PPE. PPE does change depending on what the situation is and what you're dealing with. So know what you need, know what you have, make sure you're covered, make sure you're keeping yourself safe. I'm going to run off on a tangent there. I'm going to give you an example of someone that we had back in my previous days. They had all the FR that they were supposed to have. They had all the proper equipment. We had a flash fire, okay? They did not have their FR shirt tucked in. It's hot out there and all that. That flash fire went right up underneath their FR shirt, and still they got a major burn on their torso. So out there when it's hot this time of year, you want to keep yourself cool, but you also got to keep yourself safe. So keep that FR tucked in, keep those sleeves rolled down, that type of thing. Make sure you have GSAs. The GSAs are important because they're what helps everybody recognize what the potential hazards are, what you're going to do in the event of emergency, and all of that. So make sure one's filled out. Make sure that you don't just sign it, but that you understand it. And then, of course, all this stuff, one of the biggest hazards is hydrogen sulfide. So be aware of it. You may not know it's there, so ensure you've got a gas monitor that picks up that H2S so that you can keep you and your folks safe. If you've got a 4-gas, it's also going to detect flammability, which is going to help keep you from a possible ignition. All right, gentlemen, equipment required, take it from here. And again, I'll try and keep my mouth shut, but no promises.
Okay, thank you, Dave. Of course, as Dave mentioned, PPE, that's FRCs, fire retardant clothing. Everyone knows the importance of that, like Dave mentioned. PPE again, safety glasses, hard hat, steel toe boots. We've been in this industry long enough to know what's required. Sample containers, we'll discuss that later on, or throughout the slide, I should say. What type of sample containers is very important, depending upon the test that you need ran on the samples or the fluid, or the pressure of the samples as well. Sample manifolds, of course, you don't want a dirty, beat up, rotted tubing or hosing or anything like that for your sample manifold. So sample manifold is very important as well. Sample tags, it's the importance of that is, along with the sample itself, pressures and temperatures. If there is a high H2S in that gas sample or in that sample itself, the lab needs to be made aware. So sample tags are very important that they're labeled clearly of what product you have, pressure, temperature, and so on. And COCs, same situation there. Very important that it stays with the sample and it makes its way to the lab so our customers can get the proper results that they need in a timely manner. Next slide. Oh, sorry.
Dave. Is Dave on mute?
I am not on mute. I'm sorry.
I think you still have the controls.
Of course. I apologize, everyone. My bad. I got distracted by a shiny thing.
And we mentioned this, I mentioned this in the previous slide, just the sample containers. That's a constant volume cylinder. That's a 300 cc gas cylinder is what we use it for. It's cleaned, after every sample that's being ran at the lab and distributed back into the field. So you have a clean cylinder taking a good sample for you.
If I can interject there, Jim, that cylinder cleaning is extremely important. It's extremely important that it's done, per GPA 2166. Not only, mainly for the integrity of your sample, make sure you have something there, but for those of you who are operating on federal or Bureau of Indian Affairs lands, there's now a mandate to make sure that you can document and prove that they have been cleaned. So there's steps and procedures and things that you need to have on site so that if you do get an inspector out there and they ask, you've got to be able to show them that that cylinder was cleaned prior to use. So however you're doing it, whether it's internal or lab, make sure your cylinders are being cleaned properly.
And the next slide, like what's going to be discussed, is constant volume and constant pressure cylinders. This is obviously our constant pressure cylinder. There's rupture disc on each end, which is changed out or inspected every 6 months. It's broken down once a year. It's inspected as well. This is for, like NGLs or any type of product you have or any type of test.
Liquids.
On the liquids, yes, sir, that needs to be run. And like Dave said, feel free to interrupt anytime you guys have any questions. Safe precautions. So as I just mentioned about the rupture disc being in place, 500 cc's or above, a rupture disc needs to be on your cylinder. We'll talk about thermal expansion on the CPs. You don't want to fill it greater than 80% due to thermal expansion. And low temperature products as well. That's going to cause, that has more of a risk of expanding and blowing that rupture disc and cause damage, which we'll see here pretty soon to, just cause damage in general. Outage must be taken as well for thermal expansion on the hydrocarbon liquids.
Can you explain outage?
Yeah. So outage is on a water draw cylinder, which on the water draw method, which we'll talk about here soon in a slide. Outage is just for that thermal expansion. So you have that gas cap within your constant volume cylinder as your product. If your product was to heat up, it allows the product inside of that cylinder, that gap inside of that cylinder for the expansion process. And then,
just an anecdotal, Jim, is I know that, down in South Texas at one of our facilities down there in my old life, we had a standard for one of our liquid online GCs. And, why not store it in the GC house? That seems like a good place rather than taking up room in the office and all that. Well, for those of you who have been in South Texas, it can get a wee bit warm down there. Sure enough, inside of that room got hot and we blew a rupture disc inside that little building, and it was not a happy thing. So, be careful about that.
Definitely. Static discharge, we had an incident in the field many years ago to where we were actually on location and hydrocarbons were actually being bled down into a plastic container, and a fire ignited due to that static discharge. So it's always important never to use a plastic container whenever you're dealing with hydrocarbons. Have a metal bucket and have that metal bucket grounded as well.
All right. So thermal expansion. So why do we need to follow the safe practice for not filling the cylinder more than 80%? This is the reason why. So liquid hydrocarbons, they can expand between 30 to 90 psi per degree Fahrenheit of temperature increase, and that is typically followed by the equation of thermal expansion. So as per that, it says, the change in pressure is any change in temperature multiplied by the coefficient of thermal expansion is going to be your change in pressure. So as an example, if we have a sample of liquid that is taken at, let's say, 1000 psi and 50 degree Fahrenheit, and that was filled to 100% of the cylinder volume, and we move that cylinder to a location that is 70 degree Fahrenheit. Now, as per the equation of thermal expansion, we have a thermal expansion coefficient that is 60 psi per degree Fahrenheit. We would see pressure in the cylinder increase by 1200 psi to 2200 psi, and that is not good. An example of that would be in the next slide from D.
So,
You want to talk about this?
yeah. So this incident happened at the lab there in Venus when I worked there. We had 3 cylinders come in from a client. The temperature of the sample when it was caught was around 60 degrees, but the ambient temperature was closer to 32. The clients filled them up to 80%. They had about 1,000 pounds on them. As you can see in this one, the cylinder expansion, the thermal expansion, had already taken it from 80 to about 90%. And the pressure had gone up from 1,000 to about 1,400, 1,450. The reason we have all this documented, because this was one of the 3 cylinders. You can go ahead and change slides. This is what happened when the other one, it actually ruptured. The fumes hit one of the FIDs that was lit in the lab, and we had a little bit of a flash fire, and it burned one of the employees. So it's a very serious topic, thermal expansion, and not overfilling the cylinders. It can get bad in a hurry.
All right, next.
Can I bring something up on that?
Please.
So another thing that I don't know if everybody is aware of, the rupture disc, the rating on the rupture disc, if you have an 1,800 pound rupture disc, the actual physical rating of that disc is 1,800 PSI minus 10%. And back to what Jim was talking about earlier, don't go over 90% of the pressure. That's why you don't exceed 90% of the pressure, because an 1,800 pound disc, brand new, can rupture at 1,620 pounds. So you looked at that 2,200, it may not only be 400 above the rating of the disc, it could be 600 PSI above the pressure rating of that disc. So you don't even want to get within 10% of that pressure rating. That's all I wanted to say.
That's great.
That's a good point too, Joe. And on that note, also just chime in on the rupture disc. You got to think about it as, that's why they changed out every 6 months. The hot and cold weather is that rupture disc itself is expanding and decreasing. It's actually flexing throughout time. If one sample is used or one cylinder is used, multiple times, 10, 15 times throughout a 6-month time frame, that rupture disc is actually, it's doing its job, of course, but it's actually flexing depending upon what's going into that cylinder. So that's why it's important to inspect those, change those out every 6 months.
All right, great. So before we head into the liquid procurement, let's understand what is the concept of bubble point. So what you see here is a phase diagram. It's a pressure temperature plot that describes the conditions under which various phases of a substance are present. So essentially it relates pressure and temperature to the state of matter for a given substance, for a given hydrocarbon substance. So as you can see, for a multi-component system, it covers a broad region over which 2 phases exist in equilibrium. And this curve is, constructed by joining the bubble point curve on your left that has the hollow dots, and a dew point curve on the right that has the solid dots. So if you look at the edge of on the right edge, we have the critical point. So anything on the left side of the critical point is going to be your single dense like liquid, and on the right side is going to be your gas. Your cry condensed bar is the maximum pressure on your phase envelope, and cry condensed term is the maximum temperature on the phase envelope. So anything inside the phase envelope is two phase. So if you look at the liquid region, so let's say the current conditions are 500 psi and 90°F. So if we were to undergo an isothermal expansion, that means keeping the temperature constant, we reduce the pressure, and we kept the pressure dropping until that it reached that point on the curve, and that then is your bubble point. So the bubble point is where first bubbles or vapor starts to liberate out of the liquid, and this is generally the lightest components. And as that pressure keeps dropping, you see more and more vapor coming out of that liquid. And this is something that we need to remember, which Jim will bring up in the next couple of slides, as he talks about the several methods that we sample liquid.
As Dave mentioned, GPA 2174, it lists 4 methods. So I'd like for you guys to go check out that GPA 2174. We recommend the water displacement or glycol in freezing temperatures. Obviously, I mean, you don't want your water to freeze. So in the colder areas, you can use the glycol, and it's the same concept we're about to discuss. As Z mentioned about the bubble point, you got to use caution when sampling liquids near bubble point to prevent flashing of the lighter fluids once it's transferred. I mean, your cylinder's going to the back of a truck, changing hands, so it's going to be shaking up, moving around. So you got to be aware of that bubble point. Of course, your sample point is critical. You want to collect your sample upstream of a dump valve, and to get the most representative sample of what's in that pipe, you want to get it from a sample probe that's where the product is mixing up inside the pipe, so you're getting a good sample of a product. Of course, I mentioned the dump valves. You want it to be in a single phase as well.
So we do have a question here from Richard. So when PVT sampling at separator, what size of samples for oil and gas would you normally take? So if I can answer that, I think there's not a certain rule that, like, the size is pretty standard, right, Jim? Like, depending on the cylinder, I mean, you just have to ensure that there is sufficient sample in that cylinder,
right,
that you can bring it back to the lab and test it.
That's
well,
right.
and Z, a piece of that is, and maybe Chris is a better one to answer this, but it depends on what analyses you're going to have done. And so if you're going to have multiple different stages, multiple different analyses that are performed on this, it's going to require more fluid than it would if you're just sending it in for a single one. So you need to talk to your lab and ask them exactly how much they're going to need, not only to do that analysis, but to have some redundancy. So if there's a problem, they can retake the sample, or reanalyze the sample, that type of thing. So communicate with your lab, they'll let you know, and then whoever's doing your sampling, make sure they know what size cylinder and what to grab. That's not a cop-out. It's, there's a lot that goes into that. Chris, thoughts on that, sir? All right.
Yeah, and also one thing to remember is for PVT sampling, you generally should take the sample at the first stage of separation, because then you are going to recombine that liquid and gas. That is going to represent your well stream composition, and that well stream composition then becomes your then you use that well stream composition for PVT analysis and whatever PVT experiments that you are going to run, whether simulated or in the lab. And also another question on that we have is any particular type of sample cylinder used, any special requirements, for example, large volume of gas flow through cylinders, lined cylinders, aluminum, etc.
Ooh, I'll take that one.
Okay.
And so, for standard sampling, for standard natural gas or hydrocarbon liquids, you can use, for gas, the spun steel cylinders, same thing on the liquids or your standard constant pressure. But when you start getting into reactive compounds such as H2S, now you have to start looking at something that's passivated. And so I realize we're talking about liquids, but I'm answering it for both. I apologize. On both of those, the gas and the liquid, you can get what's called Silco Steel. It's a proprietary product that was developed by ResTech, but other companies have similar products that passivate that cylinder, or you can get them Teflon lined. And that helps to keep the compounds such as H2S from reacting with that steel to where you actually lose composition. For instance, Tedlar bags, you have someone collects a Tedlar bag to get H2S. Well, it's great. By the time it gets to lab, you're going to have very little H2S. So you're going to meet your minimums because it's now all reacted with the walls of that Tedlar bag, and you're not going to recover it. So you really have to think about it when you get reactive compounds. But for your standard sampling, you can use a standard cylinder. Mr. Landis, did I miss anything there?
Nope.
Dave,
Yes.
when I worked at one of my previous companies, we had some low pressure gas areas. I know this is the liquid side, but instead of using 300, we usually 500s and 1,000 cc cylinders we would go out just to get increased volume because the sample source pressure was so low.
Yeah.
So,
Great points, Dee. Thank you.
Hey, Jim, I've got a question for you.
Sir.
You go to get your sample, and maybe I'm jumping ahead here. How do you know you're getting a hydrocarbon sample?
You will have to, as soon as you hook up to any sample, you need to purge your source to see what your product is, and just take a visual on your sample itself. See if you're getting water, hydrocarbons, whatnot you're getting.
So like an algae bottle or something?
Yes, sir. The graduated cylinder, which you're going to displace the water with anyhow.
Okay.
And I think too, Joe, when Jim gets to the point on the liquid sampling, the way that we build the sampling manifolds, we have a bleed valve so that you can bleed out some of the product into an Nalgene bottle to be able to visually examine it to make sure that it's hydrocarbon and not water.
Prior to sampling, yes, sir.
Okay.
Nope. Sorry, I clicked off the screen, so it didn't take my click. There we go.
Okay, and so we obviously collect atmospheric samples as well. API chapter 8.1 is what we follow. They list 9 means of sampling. As we mentioned with your questions as well, the container volume will depend on several factors. If getting from a storage tank, barges, ships, rail cars, we'll discuss with the lab and make sure we're getting the correct volume and using the right sample bottle itself. Same as your condensate, crude oil, lubrication. Obtaining representative samples may require sampling throughout the entire range of the tank. Of course, you're not going to, you shouldn't pull up to a storage tank and grab a sample from the top of the tank. That's not a true representative sample. You want to get it from the bottom, the middle, and the top. That's going to give you a true representation of what's in that storage container itself. And I was going to mention this on the PVT. So in the event of resampling not feasible, it's advisable to obtain duplicate samples. If a phone call comes in, we don't collect PVTs on a daily basis, several PVTs on a daily basis. If a one-off job comes in, like I call them, or a high demand request, not our common monthly sampling that we do, several hundreds of them a month, we will collect duplicate samples. So we're insured in case that rupture disc was to blow, something was to go wrong, or an upset somewhere, that we would have backup. So we do collect duplicates where needed.
Just real fast, Richard. Yes, sir. Would love to have a chat at a later date. So feel free to reach out to anybody on this team later. Oh, see, I clicked off the screen again. Sorry, that was my bad. There we go.
And here's actually what we've been leading up to, the recommended sampling method for hydrocarbons, water displacement, or a water draw method. So our sample cylinder there is cleaned out, is filled with water, 500 cc's of water. We're going to calculate 70%, which is 350 milliliters. So, and anytime we hook up our sample hose, we'll purge our source just to make sure there's not rust or any debris inside of our sample port itself. Tying our hose, hooking the sample, or hooking our sample bottle rather. And before we turn valve C, leading into our sample cylinder, valve B on the screen, that's going to be our purge. So we're going to put our graduated cylinder on valve B and you know, maybe 200 cc's or so, just put 200 cc's of cylinder inside your graduate and do a visual. So that way, you know, we don't want to come back to the lab and it turned out to be all water. We want to, you know, get the right sample, the correct sample, do a good job the first time. So it's always important to get that visual sample before you just open up valve C into your sample container. But you'll drain 350 milliliters. You'll displace 350 milliliters of water into your graduated cylinder. You'll trap in your sample, and then you're going to get your outage, which we discussed earlier in the screen. You're going to close valve C, C and D, close in your sample, and then you'll open valve D, and you'll drain out initial 20% just to get that outage for expansion purposes, what we've been talking about. And the key to collecting a good sample, have that slow drip. You want it a slow drip going into your graduated cylinder. It should take you 15, 20 minutes minimum to get a good sample. If you just open up those valves wide open, you're getting flashing and you're not going to get a good analysis on that sample when it gets to the lab. That's it for that. Glycol method, which we discussed, is the same process, except it's in the colder areas. You can fill your water draw, or you can use glycol instead of water inside. So 500 cc's of glycol would be in, and then you're just displacing your glycol. Same process though, just different fluid that you're displacing. CP method, this is for like your NGLs, or there are certain tests that the lab needs that they don't, the water will interfere with your sample, with the analysis. So of course the constant volume cylinder is filled with water. Your CP, you're just fighting pressure on the backside. So the important thing here is to have whatever your source pressure is, whether it be 900 or so, you want your backside pressure to be at minimum 100 pounds higher than your source. And you're slowly allowing as and again, you want to bleed off or purge your source valve so you don't have any debris going into your constant pressure cylinder. But with the pressure being on the backside, on your pre-charge side of your cylinder, valve D, you want that 100 pounds over source. And as product is entering valve C, entering your cylinder, you want to slowly release valve D, slowly release it because you don't want to slam that CP by any means, because the insides won't work properly. If you're slamming that product in there. Slowly release valve C, it's fighting against it, and that piston, you'll slowly see that piston moving up. Do not fill over 80%. You can fill it up 70%, and more than likely that's going to be enough for the lab, but you definitely do not want to go over 80%. As Dee mentioned in those pictures, a rupture disc goes, it's not a pretty sight. That's it for that one.
All right. Thank you for that, Jim. All right,
Absolutely.
Let's move on to natural gas sampling.
Hold on, just going back to the liquid one.
Oh, sorry, you bet.
If I was catching it and it's 30 degrees outside, I would not go above 70%.
Yep, that's a great point, because that's going to just expand when you throw it in your truck.
Mm-hmm.
But nobody has to work in conditions like that, Dee, so it's not a problem.
That is very true.
All right.
All right, so for gases, we talked about bubble point for liquids. So for gases, we need to understand the dew point and also the Joule-Thomson JT effect. So we have the same phase envelope here. On the left side of your critical point is the liquid. On the right is your gas. So gas, generally the phase envelope is on a much narrower temperature range, if you can say that. And on the top is your supercritical region. And inside the phase envelope again is your two-phase region. So if you're on the gas side of the phase envelope, and let's say our current conditions are 1000 psi and 120 degrees Fahrenheit. So if the pressure, if we were to do an isothermal expansion, and if we keep on dropping the pressure, then it will remain as a gas. But let's say due to JT effect, the temperature because of the pressure drop, the temperature also drops and the gas cools. Then we might see that current condition point to move inside the phase envelope, and you might see some condensate dropping out. So that will kind of impact the quality of your sample, you know, reduce the thermal content, and, you know, it's not going to be 100% gas inside the cylinder. And we'll talk about it, like there are some certain methods where you can ensure, you know, that you're not capturing gas. And one method that I've been told is you shake the cylinder to see if there is any liquid in it. And that's kind of your first kind of indication to know if there's any liquid or not. So moving on. So talking about dew point, as I said, any sample distortion can occur due to, you know, phase change of the gas going from a gas to liquid because you're dropping the pressure and temperature below the dew point. And it's important to keep that vapor phase of that stream at above the dew point of the flowing temperature. And to ensure that, we should make sure that the sample container is at or above the temperature of the flowing stream. And also the sample manifold is above the flowing temperature of the stream. And we also sometimes apply supplemental heat to the cylinder to make sure that the cylinder temperature itself is, you know, above the flowing, at or above the flowing temperature of the stream. So that way, when you're capturing the sample, it's all gas. All right.
Mm-hmm.
All right, D, take it on.
So GPA and API have 8 procedures that are typically used to catch a gas sample. Most people use the purge, fill, and empty, or helium pop. Helium pop can be used if it's a lot of high H2S, so you don't be exposed to it a lot. Important with the gas sample, it's kind of opposite of the liquid. We don't want liquids to drop out into the gas, or the liquids, you don't want gas to burst out when you go above the bubble point. So you have to be careful of the temperature. Your sample location needs to be in a good flowing point, not in a dead spot. If possible, take it from a probe. There are times you're going to go out and they're going to say, catch a gas sample, the inlet to the D high. Chances are there's not going to be a probe. Those things need to be noted because those samples are going to have a higher chance of having some contaminants get in there, and it's just good to know. Typically it's a 300 cc cylinder, but as I mentioned earlier, sometimes if it's low pressure, you might catch a higher volume cylinder just to be sure you have enough sample. We can go ahead to the next slide.
Yeah, Dee, I'm gonna, if you don't mind, on that sample probe, and I definitely agree that there might be the occasion where you have to grab something and it is what it is. But as Dee mentioned, you know, you get hydrocarbon liquids and that type of stuff that run along the wall of that pipe. And so you are way more likely to catch a non-representative sample if you don't have a sample probe in it. There are manufacturers out there that make insertion probes that if you just have a full port valve, you can get that probe down into the center third of your gas stream. And if at all possible, you're going to want to do that because it's kind of a crapshoot as whether or not that sample will actually show you what it needs to show you if you catch it without a probe.
So this slide shows 2 different setups used to catch a gas sample. The one on the left has a GPA separator. Typically that's not recommended. There are situations where you could use a GPA separator. I call it GPA separator, but it has to be handled correctly to work right. If it's not handled properly, it will compromise your sample. So typically we go straight from the sample source into our manifold. And so when you go out to the location, one of the first things you got to have to do is make sure it's your right sample point. But you start taking the, I'm going to bring up a safety point here, but you start taking the plug out of the valve. I don't know how many times the valve moved instead of the plug. And I started unscrewing the valve out of the probe. So just make sure that it's the plug moving, not the valve, and you're just going to open up the meter run to the air. After you pull out your sample, the plug, open the sample valve a couple of times just to purge out any trash or contaminants that might be there. You tape up your manifold, install it on the sample valve, tape up your cylinder, hook it on your manifold, and then at the bottom of the cylinder, you hook up your pigtail. Cylinder should be in the vertical position with all the valves closed. Once everything's installed, you open the sample valve, which is valve A in the diagram. Open up valves D and E. That's going to pressurize the whole system. And then we're going to close valve A. We'll open valve F almost down to atmosphere. And then we're going to close it. And that is called one purge cycle. I think the next slide
Yes, sir.
has a number of purge cycles. You have to repeat that process of opening the sample valve, pressuring up that whole manifold and cylinder, close the sample valve, and open the purge valve or the bleed on the pigtail as many times as this table there recommends. So if you're doing 100, it's about 100 pounds, you're going to do that cycle 5 times. After you've done that 5 times, you open the sample valve back up, sample valve A, you close it, open it and leave it open, close valve D and E on the cylinder. Then you can close valve A, open your vent on your pigtail, open your purge valve, and you've depressurized your manifold and your pigtail, and you have your sample trapped in your cylinder. At this point, you can take off the pigtail, unhook your cylinder off the manifold, and go take your cylinder, dip it in some water, see if your valves are leaking. Tape up the threads on the valves, put some caps on there, cinch it up tight, pull the manifold off, and then tape up the plug and put it back in the sample valve. And that one's done. Any questions?
If I may, Dee, this is one of the things I witnessed when I was out doing an audit one time. So your pigtail, its main function is to move the JT effect and any potential condensation as a result of that away from the cylinder. So that's why you have that long pigtail and that valve there. I was out witnessing a client one time, and they did a perfect purge and fill procedure. Then when they were all done, they pulled their pigtail off, opened valve E in this picture so that they could get a really good blast through that cylinder. And so they just negated everything they had done with that purge cycle. So that pigtail is there for a specific reason. You want to make sure to have that in place and to utilize it as the procedure, as Dee just walked you through.
And I actually have seen one where they had the pigtail between the sample valve and the cylinder. So interesting.
Yeah.
But that's the process of the purge, fill, and empty. At this point, you would go ahead and fill out your sample tag, your chain of custody, and all that good stuff. The helium pop method, as we mentioned earlier, is used occasionally when you have high H2S because there's less exposure to the technician. The manifold is a lot different. It's basically a T with a purge valve. The cylinder is sent to the field from the lab. It's going to have 5 pounds of helium or less. To catch this sample, once again, it's the same basic thing. Make sure your sample point's the right point. You open it up to bleed it out, any contaminants. You hook up your purge valve and your little manifold T, hook the cylinder up to it. The pressure gauge on the top is actually used when they're filling the sample. It's not actually having to be used when you're taking the sample. That would be a partial pressure sample. So what you would do, open your sample valve, open your purge valve just a little bit to purge out that sample T, close the purge valve, open your sample container inlet valve, let the cylinder fill to line pressure, you close it, close your sample valve, open the purge valve to bleed off any pressure on the T, then you took the cylinder and tape everything back up, check for leaks, and fill out your sample tags. One thing too is when you're doing this, when you're doing a meter calibration, be sure to note on your meter calibration the cylinder number so you can correlate your samples to your calibration reports. Composite sampling. One of the main things with composite sampling is setting up your sampler to fill up the cylinder, but not overfill the cylinder. So you try to get 70, 80% full on the cylinder. Set the sampling system to do a flow proportional, not time proportional, so you actually get a good representative sample. That was hard to say. Representative sample of what was flowing. And that's one of the main things with that. To go out there to change it, you isolate the sampler from the system, open up the, pull off your sample cylinder, you put on a new evacuated cylinder, purge the line just a little bit before you completely seal the new cylinder on there. Then you open up the isolation valve and it's back in service.
One thing I want to throw in here, D, is the importance once again of heating here. You know, these things need to be maintained. You know, you're collecting a sample over whatever, you know, settlement period you have, let's call it a month. And you have to make sure that, just like with the spot sample, only it's a longer period, that you're maintaining temperatures above the hydrocarbon dew point the entire time. I'll give you a direct example. Again, in my previous life, we were delivering into a pipeline company. That pipeline company, although repeatedly asked, refused to put a heated composite sampler on there. So we put our own on there. This stuff had a hydrocarbon dew point, if I remember correctly, it was around 63 degrees. And this was in Kansas. And those of you who are in Kansas probably know that it will occasionally get well below 63 degrees. And so we put on our own sampler and, you know, did parallel sampling. And we were coming up with anywhere from 3 to, I believe it was 45 BTU different. Over the 2-year audit period, that cost us almost $2 million in loss because of the reduced heating value of the gas due to the condensation dropout. So you want to make sure that's heated, because otherwise you're not going to get a representative sample. You'll get dropout in the manifold before it even gets to that cylinder.
Yeah, we have 2 questions here, Dave.
Okay.
So what are some of the companies that make insertion probes? From question from Cameron. And the second question is there any preference to the type of valves used in the spot sampling process, such as full port, quarter turn valves, quarter-inch turn valves versus needle valves, etc.?
I'll take the first one. The first one on the insertion probes, the one that I'm familiar with is built by A+. I'm sure there might be a couple others out there. I don't know off the top of my head, but they have varied styles. From
Welker makes those.
I'm sorry?
Welker and I think YZ both, I'm sure that Welker does, and possibly YZ.
YZ does too, yes, sir.
Perfect. So they have them where they're designed to where if you've got a flowing stream that you don't want to shut in and you want to put in a permanent one, they have those that are more for a permanent in situ situation. And then they have those that are portable that you can take from run to run to run, whoever's out there collecting the samples. They have them with membrane insertion, membranes at the tip, and they have them without. I bring that up because, you know, separating at flowing temperature and pressure is the way to do it. So you would want the membrane at the tip, but for some reason the BLM doesn't like that. And so at least currently in the rules, you cannot use a membrane tipped probe. So someone else want to take the valve question?
Is there any preference to the type of valves used in spot sampling process?
You want to take that, Joe?
I believe 14.1 says that you should use a full port needle valve.
Yep.
I see. So it's driven by the standard.
Yeah, and I think that's going to be in API 14.1.
I see. So sample tags. So every instance we take a sample out on the location in the field, we have to create a sample tag for it. So this is just for us in the lab. That way we can track the sample from start to the end. So typically the information that we capture is the sample date, the time at which the sample was taken, the method, whether it's spot, composite, flow proportional, if it's composite, time proportional, where the sample location is, what's the name of the sample location, if there is any station number for that sample, what's the sample point pressure and point pressure and temperature, the technician who's collecting the sample, the name of the technician, is there any contaminants in the sample, whether H2S is measured or CO2, etc. Any additional comments you may have, for example, this is for H2S and this is like the sample had H2S in it. So just things like that. Next slide, please.
Real fast here. For those of you who are on BLM properties, if you're going to do actual moisture measurement, your two choices are either calculate your heating value as dry or have a true measured value for your water. If you're sending it into a lab, the lab's not going to do the water for you. You have to do it on site. So here's where you would write down your moisture concentration on the tag so that when you send it into the lab, they can include that in your heating value calculation.
This is what our typical paper tag looks like. So as I mentioned, all the information that we capture here, going from the cylinder number, the company that we're pulling the sample for, the location, sampled by, and any other relevant information that you think would be useful at the time of taking the sample. Next slide, please.
But Z, what if I don't want to use paper tags?
Well, I do have a solution for that. So that paper tag is currently in the process of going digital. So we have an app now called SureView where all the sample information that the technician collects at a location is now collected through the phone, through a phone device. So typically you would have your phone scan the cylinder tag, and then that cylinder tag will automatically be captured for a new sample. The date and time will be captured as for whatever the device, as per the device. Then you'll have to specify what type of sample it is, whether it's gas, liquid, condensate, water, whether if it's a spot or composite. You'll identify note down the source pressure, the sample pressure, temperature, ambient sample temperature, ambient temperature, if you're measuring H2S, and any remarks. And once you save all that information, it uploads it to our SPL servers, and then that information is sent to the lab as well, saying that a new sample tag has been created. And then there's also a way for you to then track that cylinder in time. So if your cylinder has been, let's say, has been delivered on site, then you'll have a notification saying that the cylinder was delivered on site. Then when it is picked up by a technician, then you'll get a notification saying that the cylinder was picked up. And when it was dropped off in the lab, you'll get a notification that the cylinder was dropped off. So that way it gives you a streamlined process of your stages of the chain of custody, as the cylinder sample exchanges hands. And not only can you save the sample information, but you can also visualize, you can also see the report once it's published by the lab. So instead of waiting for an email report, so as soon as the lab pushes the report out, you can see, you'll get a notification and you can see that report for your sample at the palm of your hands. And an additional feature is you can now track the history for that sample going back to 4 years. So you can just trend that data over time. And you'll also have the functionality to export into a CSV format so that you can send that file as an import file to systems like Flowcal, or any other software that we're using. So this is an ongoing product that we've been working on, and we're adding functionality, and we are welcoming feedback from our users if they want us to see any other calculations, that would just get rid of the paper tag. So, and something that we've been working on is the density measurement that currently is still written on a piece of paper, and that is also, we are digitizing that as well. So pretty cool stuff. So chain of custody, Jim, do you just want to
Sure.
You mentioned that.
So of course, the COC, the chain of custody, I mean, it's a legal document. It ties into the sample tag, pretty much same information is on the sample tag. But this is just, again, so it runs through the lab smooth to get you guys timely results. It just follows the sample through the lab. And it mentions the testing you want, whether you're looking for C7, C6, whatever you may be looking for, the testing, the time, the date, not the pressure, temperature, time and date is on that sample and the testing needed.
All right. I think that's pretty much it.
All right, everybody. Well, we appreciate
Probably the most important thing on that chain of custody, though, that's different from a sample tag, and I just wanted to bring this up, is in the event that this became legal, or if you're using it for any environmental type samples, knowing the chain of custody is very important. So if something were to happen to the sample in that process, you'd be able to possibly attribute a cause. That's all.
No, that's perfect, Joe. Well, again, we want to thank you all for taking the time for joining us for this. I hope you're getting as much out of it as we are. I know we love doing this stuff. We're going to continue to have these, as we mentioned, monthly basis. So we'll have a new episode coming up next month. I don't think we've quite decided on what that is, but if you all have a suggestion or would like us to cover something, don't hesitate to reach out. We covered sampling this time because that was specifically asked for by some of the attendees at the previous webinar. So again, be safe out there, especially with a hurricane, for those of you who are in Texas and Louisiana. And if you need anything, don't hesitate to holler at anybody who's on this screen. And we look forward to talking to you on the next one. So thanks,
everyone.
Steve,
Bye,
thanks
guys.
everyone.